We're going to learn how to calculate titration 2 experiment data, which is for determination of mass percent of antacid. Okay, so first things first is you will need the average molarity of sodium hydroxide from the previous experiment. This number will not be the same as your average, so you'll have to use previous experiment's average, which is trial 1 plus trial 2 plus trial 3 divided by 3. And then let's say you come up with an average of 0.1032 molarity, that will go over here. So make sure you copy this number over from your previous lab's data. All right, molarity of HCl is given 0.1192 molarity. Mass of antacid that's used is 0.1737 grams. Initial volume of HCl to dissolve the tablet is 0.13 mils, and then you have 18.76 mils as the final volume. Now, the theory behind this experiment is basically we are using sodium hydroxide as a base. Antacid is also a base because antacid works by neutralizing acid. So antacid over here could be neutralized with any acid, right? So, but the problem is over here, we're going to use NaOH here to use that to try to neutralize the HCl antacid. So over here, what we do is antacid needs to be dissolved completely in hydrochloric acid. So we'll put in excess a whole bunch of hydrochloric acid basically to make sure that even though antacid is basic, you put a whole bunch of HCl in, it's going to make overall that thing acidic, and then you can just titrate a little bit of sodium hydroxide to make it go to the endpoint, which is a light pink color. So over here, we'll use an excess amount of hydrochloric acid. Some people use between 15 to 20 milliliters. It depends on the experiment. So the student here, the data set will be 18.76 mils as a final. Initial volume of the burette and for the HCl was 0.13 milliliters. And then you'll have a second burette. After you cook the HCl antacid a little bit, you heat it up a little bit, and then you cool it back down to room temperature, and you will titrate with the sodium hydroxide. And the volume of sodium hydroxide you used here is basically initially, they had 12.26 milliliters, so they didn't fill the burette all the way up to 0. That's okay. And then you have 20.19 milliliters as the final. So from here, you can find the volume of sodium hydroxide used here as well. So the step 1 to calculate this, we need to calculate volume of HCl added to dissolve the tablet. So remember, we put an excess of HCl to dissolve the tablet. So the HCl plus tablet is a little bit acidic, which will then be neutralized by the sodium hydroxide. So let's go ahead and calculate the volume of HCl. Volume of HCl will be final volume of HCl minus initial volume of HCl. In this case, it would be 18.76 milliliters minus 0.13 milliliters. So let's see what that comes up to. I get 18.63 milliliters. Okay, so volume of the sodium hydroxide used again is final of sodium hydroxide minus initial of sodium hydroxide. So we will have 20.19 milliliters minus 12.26 milliliters. So this is milliliters of HCl. This will be milliliters of NaOH. So in this case, there's 7.93 milliliters of NaOH. Now, can we get the moles of hydrochloric acid? Yes, because we have the molarity of hydrochloric acid up here. All we do is convert this to liters, which is divided by 1,000. So let me go ahead and put the calculation down to get moles of HCl. So you take 18.63 milliliters of HCl, and we know that 1 liter of HCl contains 1,000 milliliters of HCl. This is where you divide it by 1,000. And then we will use that to multiply with the molarity because it's 0.1192 moles of HCl in 1 liter of HCl solution. That's what the molarity stands for. Let's go ahead and get this moles of HCl done. And in this case, I get 2.221 times 10 to the minus 3 moles of HCl. So what about the moles of sodium hydroxide? So the moles of sodium hydroxide here, we have the molarity from the average of last experiment. And then we also have the volume right here, okay? Which is, we figured out it was 7.93 milliliters. So we'll take 7.93 milliliters of NaOH, divide that by 1,000 because we're converting it to liters. Then we'll use the molarity, the average molarity for sodium hydroxide from last experiment. I'm going to use the number 0.1032 moles of NaOH. Your answer will probably be different in this one. It won't be this number. In 1 liter of NaOH. So we'll get moles here. Let's calculate this. I get 8.18. So I'm keeping 3 cyclics here. Okay, so 8.18 times 10 to the minus 4 moles of NaOH. Okay, so the next step here is saying how much of the HCl was neutralized by sodium hydroxide. So remember, the HCl is excess acid. And there's 2 bases that's in the beaker now in your flask. So the first source of base is sodium hydroxide. The next source of base is the antacid tablet. We have excess HCl, so HCl is the only acid. We have 2 bases here. So the first thing is HCl and NaOH reaction is 1-to-1 mole ratio. So basically, moles of HCl that's neutralized with the NaOH is basically all the moles of NaOH here has been neutralized by the same exact amount of HCl. So over here, basically, this is the same number as over here. Moles of HCl that was neutralized by the sodium hydroxide is all the moles of sodium hydroxide because it's 1-to-1 ratio. So over here, it's 8.18 times 10 to the minus 4 moles of HCl that's neutralized by NaOH. Okay, so this one here, neutralized by NaOH, let me write it down. So the leftover HCl was neutralized by the tablet. So how much is the leftover? Well, we know the total is 2.221 times 10 to the minus 3, and we used up 8.18 times 10 to the minus 4 to neutralize with sodium hydroxide, which is one of the base. So the second base will be basically this value of HCl minus this value of HCl. So let me write it down. It will be 2.221 times 10 to the minus 3 moles of HCl that you calculated from the whole titration because you used a whole bunch of HCl and part of it was neutralized by NaOH. So this is what you subtract out, 8.18 times 10 to the minus 4 moles of HCl. Then you will get the moles of the HCl that's neutralized by the tablet. So in this case here, let's go ahead and do that math. I get 1.403 times 10 to the minus 3 moles of HCl neutralized by antacid. So now that you have the moles of HCl neutralized by the tablet, we can actually then say, well, that over here we can get moles of calcium carbonate. So the HCl to calcium carbonate ratio is actually 1 mole of calcium carbonate to 2 moles of HCl. So basically you have to take this number that's neutralized by the tablet, and we'll have to do the mole ratio of calcium carbonate to 2 HCl. So let me work on that over here. Some space right here. So it will be 1.403 times 10 to the minus 3 moles of HCl and 1 mole of CaCO3 is to 2 moles of HCl. So basically divide the answer by 2. So this will give me, let me divide that by 2. 7.015 times 10 to the minus 4 moles of calcium carbonate. Once you have the moles of calcium carbonate, we can convert it to grams of calcium carbonate by multiplying with the molar mass. So take 7.015 times 10 to the minus 4 moles of calcium carbonate. And we know the molar mass is 1 mole of calcium carbonate weighs 100.09 grams of calcium carbonate. So that will give me 7.00, so we're keeping 4 suffix, 009 times 10 to the minus 6 grams of CaCO3. Oh, actually, my bad. This was upside down. It's not divide, it's multiply by 100. Hold on a second. Let's fix that real quick. All right, so 1 mole goes on the bottom because I'm trying to cancel out the moles, and I know it weighs 100.09 grams. So let me redo that real quick. And you get 0.07021, keeping 4 suffix, grams of CaCO3. So then if we have the grams of CaCO3 and we have the total grams of the tablet, which is up here in our data, 0.1737 grams, okay? So to get the mass percent of the tablet, you will take 0.07021 grams of the calcium carbonate that you just calculated, divided by the total mass of the Antacid tablet, which is 0.1737 grams of Antacid tablet, and then you multiply that by 100. That will give you the mass percent of calcium carbonate. So take this number divided by 0.1737 times 100. I get 40.42%. So that's mass percent of calcium carbonate in Antacid. That means every time you have Antacid, 40% of it is the calcium, the active ingredient, calcium carbonate, about 40%. So to get the average of the calcium carbonate, you'll just take the value, the average mass percent of trial 1 plus trial 2 divided by 2. So let me write it down here. Trial 1 plus trial 2 divided by 2, that will give you the average.